now imagine you're firing a cannonball. So you're here firing a cannonball. Let's say you're aiming at a certain target. So or you could be playing golf and you're aiming at a certain target. You are aiming at this target here. So if you hit a golf ball, let's say it lands here. Okay. So this is your side view. This here is your bird's eye view. It's you looking from the top. Um, so when you hit it and it lands, let's say it lands here, that corresponds to, let's say, here. Okay. Or you could hit it and it could land somewhere here. So that corresponds to you landing here. Okay. Or you could undershoot, so it lands here. So looking from the top, it could land anywhere along this line here. Along this line here. If it lands here, you looking from the side, it will still land right here. If the golf ball lands, let's say, not here, but here, the side view, it will still look as if you're landing at the same place. Okay, so this is your side view, this is your bird's eye view. So you could hit the ball and it overshoots. So it's you landing somewhere over here. Or you could hit it and it lands here. So that corresponds to somewhere, you landing somewhere around here. Or it could be here, or it could be up here. Okay, so you hitting the golf ball, let's say you hitting it, let's say it lands here, that corresponds to around here. Okay, so but the thing is, if you keep on doing it, if you keep on hitting it, after a while you will build up a graph looking like this. Okay, so let's say, hang on, let's say you hit a golf ball and it lands here. Okay, it lands here, so that corresponds to here. Let's say you hit it, and let's say you hit another one, it lands here. That corresponds to around here. Let's say you hit another one. Let's say you undershot it, and it lands somewhere around here. Okay, but the thing is, if you keep on hitting it, you're gonna, because you're aiming at a certain target, because you're aiming at a specific target. After a while, you build up a bell-shaped curve. Okay, because you're aiming at a certain target, you're more likely to land around your target as opposed to around here. You're more likely to land around your target. So hang on. So if you keep on doing it, after a while hang on, you're going to build up a bell-shaped curve because you're aiming at a specific target. Once in a while you probably get one around here. Once in a while you're going to probably get around here. But overall, most of the time you're going to land around where you're aiming at. So after a while you're going to get a bell-shaped curve like this. Okay, so you looking at bird's eye view, it would look like this. Because you're aiming at a certain target, you're more likely to land around your target. Once in a while, you probably get one out here. Once in a while, you probably get one around here. But the point is that after a while, it's going to be really dense around here. But then once in a while, you probably miss and get it around here. But the point is that around your target, it's going to be really dense. It's going to be really dense, and then it gets around your target it gets really dense, but then after a while, so around here it's really dense. But then as you move further out, it's less dense. So you're going to get a graph looking like this. So we would use this graph to model anytime you're firing something at a certain target. This here is a good model of it. So a good golf player will have a model looking like this. We'll have a model. So a bad golf player, this here is quite wide, but a good golf player would be the width here would be really narrow. So it would be something like this. So this here would be a good golf player because a good golf player will probably land around here. A bad player, you're going to have a massive width here. A good golf player, you're going to have a good golf player will probably get it around here. Okay. Well, the point is that we're going to use this bell-shaped curve here to model probability. Okay, if you well we would use this equation here. A number of hits, number of hits, e equals c e and then to the power of minus x squared here. We would use this to model this. So if you get a graph plotter and plot y equals e to the power of minus x squared, you would get this this shape, this graph here. So we would use this to calculate to well, I will explain in the next video. Okay, but in the future we're going to calculate. Let's say you want to know the probability of you getting within 2 to 3 meters of your target. So 2 to 3. Let's say from here to here is 2, and here hang on. Let's say from here to here is 2, and from the center to here is 3. So it's really you getting it within this region here. Okay, but I will explain it in the next video. Okay, but the point is that we would use this to model our golf situation. So this thing here, remember when you're looking from the side view, it will give you this bell graph here. When you're looking at from the top, it's dense around here, but then it's sparsely populated around here. But the thing is, when you think about this, you've got to think of it as you revolving. Hang on, you're going to get something like this. It's you rotating this 360 along the y-axis. So we've got to combine the volume with the x here represents a distance, and then the height here represents the frequency at which you're hitting that target. So you've got to combine the two. Well, combining the two is you creating a volume. It's you creating a volume. This sort of bell-shaped 3D dimensional object. So you've got to combine the height with the width here. So you've got to think of this as being a 3D object. You've got to combine the volume with the distance to give you a 3D object. I will explain more in the next video. Okay.